All right, welcome Algebra 2 students. This video is going to cover the notes for 3.1, which is going to involve simplifying radicals and introduce something called imaginary numbers to us. All right, so the first thing we're going to look at are just kind of a little review of evaluating square roots. So the square root of 49 is basically the number that we can multiply by itself to get a product of 49. So hopefully we're thinking of 7. The square root of 144 is 12. The square root of 81 is 9. The square root of 196 is 14. And the square root of 25 is 5. So, there's a question here that says, explain in words how you knew the square roots of those values. For some people, they might just say they memorize them or they know it. But really, the reason that we know the square roots of those numbers is because those numbers are perfect squares. All right, so to me, all of those values were perfect squares. Which is the result of multiplying any number by itself. All right, so then we have this example down here that says, does the square root of negative 36 have a solution? Why or why not? Well, up to this point, the answer would be no. And the reason is because there is not a number that we can multiply by itself and get negative 36. If we multiply 6 times 6, we get positive 36. If we did negative 6 times negative 6, we're also going to get positive 36. There is no way for us to multiply two real numbers together, okay, the same number, and get a negative value. So that's why there would not be a solution. Okay, so no, there is no number, let's say no real number, that when multiplied by itself equals a negative. All right, but that idea brings us to the next concept. All right, so in this unit, one of the things we're going to introduce is something called an imaginary number. And the imaginary number is going to use the variable I. I is equal to the square root of negative 1. So because of that, we could take that square root of negative 36 that we had above, and we could rewrite it as the square root of negative 1 times the square root of 36. Well, the square root of negative 1 is I. The square root of 36 is 6. So now we have the ability to say that the square root of negative 36 is equal to 6I. All right. So one of the main ideas to think about here is whenever you have a negative number underneath the square root, we are going to take out the I. Okay. I is that imaginary number that we are going to be able to take out. All right, so using that same idea, we've got a couple other expressions. So all we've done is taken those square roots from the front page and put a negative in front. So the square root of negative 49 is now going to be the square root of negative 1 times the square root of 49, which is I times 7, or 7I. Okay. So the easiest thing, you could think about this even simpler, is whenever you see that negative underneath, take out the I. I root 144 is 12I. All right. And eventually you're going to get to the point where you're just going to recognize that, all right, the square root of negative 81, that's 9I. The square root of negative 196, that's 14I. And the square root of negative 25 is 5I. All right, now, we're only going to explore two powers of I. So I is equivalent to the square root of negative 1. which means that I squared is going to be the square root of -1 quantity squared. Well, anytime you square a square root, they're inverse operations, so they cancel each other out, which means that I squared really is -1. So that's going to be an important idea in this unit. All right, so when we see the square root of a negative, we're going to take out I. If we have I squared, then that's going to be equivalent to -1. All right, and we're going to ignore the rest of the ideas of powers of I. That's just a concept that's not super important to what we're doing, so we're going to skip that right now. And we're going to go to the next page. All right, so the next thing we're going to do is we're going to simplify radicals. So when we simplify radicals, we want an answer that has no factors under the radical that are perfect squares and no negative under the radicals. So many times what people are going to do is they're going to look at the square root of 54 and they're going to start making a factor tree. So when I do a factor tree, I'm always going to start with 2, and I'm going to use 2 until 2 doesn't work anymore. So in this case, that's going to be 2 times 27. 27 is an odd number, which means 2 does not go into it. So then I'm going to go to 3. 27 is 3 times 9. 9 is 3 times 3. So by doing that, what I'm looking for pairs. Because whenever there's a pair, when I multiply them, that's a perfect square. So I've got a pair of 3's here, which means I can take a 3 out of the radical. I've got a 2 left and a 3 left. So underneath the radical is 2 times 3, which is 6, and that is the simplified version of the square root of 54. One thing of note to kind of pay attention to is once I've factored 54 as 2 times 27, I no longer look at 54. 27 was 3 times 9. I no longer look at 27. 9 is 3 times 3, so I'm no longer looking at 9. So I'm only focusing on those factors that are on the outside. All right, let's take a look at number 2. So now for number 2, the only addition is now there's a variable. So a lot of times what I'll do is I'll break it out. I'll separate the square root of 48, and then I'll separate the square root of x cubed. So if I'm going to use that factor tree method, start with 2. 2 times 24, 2 times 12, 2 times 6, 2 times 3. I was looking for pairs, so I've got a pair of 2's and another pair of 2's. Over here, I've got x cubed, which is x times x times x, pair of x's. All right, so what's going to happen to get our final answer is if there's a number in front of the radical, I'm going to start with the radical, or that number, so -2 in front. Anything circled, I'm taking out, and I'm multiplying it by that -2. So I'm going to multiply by 2 again, and by x. Any of the values that did not have a pair are going to stay under the radical. So I have a 3 and an x, which means 3x stays under the radical. And then at that point, I'm going to just simplify. -2 times 2 is -4. -4 times 2 is -8. -8 times x is simply -8x, square root of 3x. So now none of the terms under their square root are perfect squares. All right, moving along. Now, number 3 has a negative underneath the radical. So the first thing I'm going to do in that situation is I'm simply going to take out I. And I'm going to rewrite this as I root 75. So then I'm going to work on my factor tree. 2 doesn't go into 75. So I go to 3. 3 times 25. Now, I could continue, kind of breaking down 25. But one of the goals is we're trying to find the largest factor that's a perfect square. So if you see that, you can stop. Because 25 is a perfect square. It's 5 times 5. There's our pair that we can take out. Here is the number that's left. So our final answer, we're going to take out the 5 and multiply it by I, so that's 5I, and then we have the square root of 3 left. And in example number 4, again, we have that negative underneath the radical again. So the first thing I'm going to do is take out the I. So I'm going to rewrite this as I square root of 56. Then I'm going to work on my factor tree. So 56 is a perfect square, or sorry, it's not a perfect square, but it's an even number. So that's 2 times 28. 28 is 2 times 14. 14 is 2 times 7. You want to keep factoring until all of your factors are prime, or you hit that perfect square at the end. So in this particular case, we have a pair of 2's that we can take out. So we have 2I, and then under the radical, we have a 2 and a 7, which when we multiply is 14. All right, so that kind of goes through how do you simplify radicals that have negatives underneath potentially, or is a product of some number and a variable. That's going to be the end of the first video. There is going to be a second follow-up video to go over the rest of the examples. So make sure you check out video number 2 and have a great day.